My dear students, today we will see the relations between rectangular coordinate variables and cylindrical coordinate variables. We have studied rectangular coordinate systems. What are the variables in rectangular coordinate system? X, Y, Z. We have studied cylindrical coordinate system. What are the variables? Rho, phi, Z. Now we will find the relation between rectangular coordinate variables and cylindrical coordinate variables. First we express Cartesian coordinate variables in terms of cylindrical coordinate variables. Rectangular coordinate variables in terms of cylindrical coordinate variables. We will choose a point P in the coordinate system. This is x-axis, this is y-axis, and this is z-axis. This is rho, radius of the circular cylinder, find the angle. Take the projection on x-axis. It is at 90 degrees. This is x. Similarly, take the projection on y-axis. The value of this projection is y, and this is also y. This is rho, this is phi, and z value is like this is z value, and p is equal to rho phi z. Now take the value of cos phi. Cos phi is equal to x by rho, or x is equal to rho cos phi. Sin phi is equal to y by rho. Y is equal to rho sin phi, and z is equal to z. Z coordinate is same in Cartesian coordinate system and cylindrical coordinate system. Now we will write three variables at one point. So x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. So we are expressing rectangular coordinates in terms of cylindrical coordinates. Now we express cylindrical coordinates cylindrical coordinates in terms of Cartesian coordinates. Just now we calculated x is equal to rho cos phi. X is equal to rho cos phi. Y is equal to rho sin phi. Rho is equal to. Now x square is equal to rho square cos square phi, and y square is equal to rho square sin square phi. X square plus y square is equal to rho square cos square phi plus sin square phi is equal to, this is 1, so this is rho square, and rho is equal to square root of x square plus y square, and calculate tan phi. Tan phi is equal to, from this one, tan phi is equal to y by x, or phi is equal to tan inverse y by x. And z is equal to z. Z is common in both coordinate systems. So writing at one point, rho is equal to square root of x square plus y square, phi is equal to tan inverse y by x, and z is equal to z. By using these equations, we are transforming Cartesian coordinates into cylindrical coordinates, and rho is the radius of circular cylinder. Rho should be greater than or equal to 0. When rho is equal to or greater than 0, then you are getting positive sign for the radius, and the value of phi is chosen. The value of phi is chosen by seeing the signs of y and x. Transformation of the vector. Transformation of a vector from one coordinate system to another coordinate system. From one coordinate system to another coordinate system. For example, if a vector is given in Cartesian coordinate system, we can convert this Cartesian form to cylindrical coordinate form. If the vector is given in cylindrical coordinate system, we can convert that one into Cartesian coordinate system within simple ways. First we will express the vector in Cartesian coordinate form. Vector A is equal to Ax into unit vector in x direction plus Ay into unit vector in y direction plus Az into z direction. A is the vector, Ax is the component of vector A along x axis. Ax is unit vector in along x axis. Ay is the component of vector A along y axis. Ay is the unit vector along y axis. Az is component of vector A along z axis. Az is unit vector along z axis. Now we will express vector in cylindrical coordinate system. This is in a Cartesian coordinate system. A is equal to A rho into A rho plus A5 into unit vector A5 plus Az into A. This is component of vector A along rho. This is component of A along y. This is component of vector A along z direction. These are the unit vectors. Component of a vector in desired direction can be obtained by multiplying that vector with unit vector in that direction. For example, if you want to get 0, you want to multiply A with unit vector in that direction. Similarly, if you want to get the component of A5, multiply the vector A with unit vector in that direction, that is A5, and Az is equal to A into Az. Component of vector along rho is equal to vector into unit vector in that direction. So A is given by Ax plus Ay into Ay plus Az into Az. A rho is equal to A into A rho. This is Ax plus Ay into Ay plus Az into A rho. Expanding this one, A rho is equal to Ax into Ax dot A rho plus Ay into Ay into Ay into A rho plus Az into Az dot A rho. Az and A rho is at 90 degrees. So cos 90 is 0. So this term becomes 0. So what is the remaining terms? A rho is equal to A rho is equal A rho plus AY into unit vector along y direction into A rho. Similarly, A phi is equal to AX into AX plus AY into unit vector along y direction plus AZ into unit vector along z direction dot A phi is equal to AX into AX dot A phi plus AY into AY dot A phi plus AZ into AZ dot A phi. The angle between these two is unit vector is 90 degrees. Cos 90 is 0. The value of this term is 0. So A phi is equal to AX into AX dot A phi plus AY into AY dot A phi. And third is AZ is equal to A into AZ. The vector is given by AX plus AY into unit vector in y direction plus AZ. This is AX into AX dot AZ plus AY into AY dot AZ plus AZ into AZ dot AZ. The angle between these two is 90 degrees. Cos 90 is 0. This term is equal to 0. The angle between AY and AZ is 90 degrees. Cos 90 is 0. So the value of the term is 0. Only this is the angle between same vectors is 0. Cos 0 is 1. So AZ is equal to AZ. To know the complete information of transformation of the vectors, we have to find out the values between AX, A phi, AY, A phi, AX. So we have to find out the values. AX dot 0, AY dot 0, AX dot A phi, AY dot A phi. For this one, we will write the unit vectors in Cartesian coordinate system and cylindrical coordinate system. This is AX. This is AY. This is AZ. Unit vectors in Cartesian coordinate system. Similarly, we will write unit vectors A rho, A phi, A rho, A phi, AZ are the unit vectors in cylindrical coordinate system. The angle between AX and AY is 90 degrees. The angle between two coordinates of cylindrical coordinate system is 90 degrees. This is 90 degrees. Similarly, the angle between these two is 90 degrees. And this is phi. This is phi. And what is the value of this one? This is 90. This is phi. So this is 90 minus 1. This angle is 90. This is phi. So this angle is 90 minus phi. And what about this angle? This angle is 90. This angle is 90. This angle is 90 minus phi. This angle is 90 minus of 90 minus phi. This is 90 minus 90 plus phi. So this angle is phi. Now we will find out the values of AX here. So this is AX, this is rho. The angle between these two is phi. Dot product means cos of this angle. Cos of this angle. So cos of this angle is cos phi. So AX, A rho is equal to cos phi. And the angle between AY and A rho. This is AY and this is A rho. What is the angle? Angle is 90 minus phi. The dot product is cos of this angle. Cos 90 minus phi. AY dot A rho is equal to cos 90 minus phi. Cos 90 minus phi is equal to sin phi. And next one is AX dot A phi. The angle between these two is AX and A phi. The angle between these two is, this is phi, this is phi, and this is 90 minus phi, and this is phi. So this is final value is 90 plus phi. So the angle between AX and A phi is 90 plus phi. Dot product means cos of 90 plus phi is equal to minus sin phi. And last one is AY dot A phi. The angle between AY and A phi is phi. Dot product means cos of this angle. That is cos phi. So we got the values of AX dot 0, AY dot 0, AX dot A phi, AY dot A phi. Now we will write dot products of unit vectors in cylindrical coordinate system and Cartesian coordinate system. Dot products. Dot products of unit vectors. Dot products of unit vectors in Cartesian coordinate system and cylindrical coordinate system. So this is ax dot, ay dot, az dot. And we got the values, substitute that values. A rho, A5, AZ. Ax dot A rho is A dot, Ax dot A rho is cos. Ax dot A5 is minus sin phi. Minus sin phi. The angle between Ax and Az is 90 degrees. Cos 90 is 0. Yes. Ay dot A rho. Ay dot A rho is sin phi. Sin phi. Ay dot A5 is cos phi. And the angle between AY and AZ is 90 degrees. Cos 90 is 0. And the angle between AZ and A rho is 90 degrees. Cos 90 is 0. And the angle between AZ and A5 is 90 degrees. Cos 90 is 0. And the angle between AZ and AZ is, the angle between the same vectors is 0. Cos 0 is 1. So, dot products of unit vectors in Cartesian coordinate system and cylindrical coordinate system. Now we will convert one coordinate system to another coordinate system. Converts now. Conversion of a vector from cylindrical coordinate system conversion of vector from cylindrical coordinate system to Cartesian coordinate system. This one is Ax, Ay, Az is equal to the vector cos phi minus sin phi 0 sin phi cos phi 0 0 0 1 0 A5 so Ax is equal to A rho cos phi minus A5 sin phi. Similarly, Ay is equal to A rho sin phi, A5 cos phi. and Az is equal to Az. Conversion of a vector from Cartesian coordinate system to cylindrical coordinate system. A row, A phi, A z. Transpose this one. Cos phi minus sin phi 0. Sin phi cos phi 0 and 0, 0, 1. And this is Ax, Ay, Az. Converting Cartesian coordinate variables to cylindrical variables. And here A row is equal to Ax cos phi plus Ay sin phi. A phi is equal to minus Ax sin phi Ay cos phi, and Az is equal to Az.